Hey grade 9s, it's Mr. Johnson coming to you live via YouTube for Math with Mr. Johnson. So what we're going to talk about today is, well, how's our learning been going? What can we do to change it? What is the flipped classroom? How's it going to help us? What will it kind of look like? We're going to answer all these questions in today's little lecture. It's given to you via YouTube, and it's given you the opportunity to possibly see what your future class might look like. So the reason why I'm doing this is because I want to switch things up. If you think about a traditional classroom, so much technological advancement has happened in our world, but not so much in our classroom. So what I want to do is I want to flip our classroom. I want to put more technology in our classroom, and I want to focus more on learning. Okay, so I'm going to need your help, and I'm going to need your participation to be involved in class and outside of class to be successful at these particular topics. And I think it's going to reap the benefits on both sides. I'm going to see what you can do, more hands-on, and then also you're going to be able to even rewind me and replay lectures. You're going to get your parents involved, maybe your grandparents or your siblings, help you out, and they're going to be able to see what I'm doing in the classroom with you before it even happens. So we're going to talk about what is the flipped classroom. So if we think about our current classroom model, I might lecture, I might talk from anywhere between 20 to even sometimes 40 minutes. And you as students can only sit there and listen for so long without your attention might be going off, or there might be some interruptions in class, or so-and-so is distracting you, or you just might not be in the mindset to learn. Well, in this case here, what we're able to do is we're able to take the original classroom model of you sitting there listening to a lecture for a long period of time and then applying that knowledge with a short period of time, like let's say 15, 25 minutes or something like that, and then you go home at homework, but you don't have a teacher at home to answer all your questions. Well, that's all going to change, because what we're going to do is we're going to take the classroom and flip it. So this is a flipped classroom model, where before class even starts, before the school class starts, you're going to watch a video of me preparing you for the next lesson. So before we even get in the classroom, you already have the information. You're going to be able to take notes on your own. And then when you get to class, then you'll have that background knowledge and that prior knowledge to apply it in class as it happens. And then afterwards, you're going to be able to check your understanding and possibly extend your learning through other possible videos or activities that prepare you for the next class. Why is this beneficial for you? Because it gets you more engaged with your learning, gets you more hands-on, gets you to experience more things as a student and come to class with questions, and therefore you're more engaged. If you have some inclination of what's about to happen, you might be more interested in it than rather just coming in and saying, oh, this is what the lecture is. So it's going to be beneficial for you as a student to see what we're doing, and even for your parents. Let's say if you don't understand something, your parents can actually help you by being able to view the videos and then possibly helping you out. Or let's say you're on your own and you want me to be able to explain something again. Well, you can always click the rewind button. Okay, it's like all the YouTube stars say, well, at the click bar down below, you can actually rewind me. How often have you ever been able to rewind a teacher? Never been done before. So you'll be able to maybe listen to the explanation again, because as a teacher, just like now, I can talk kind of fast. And we need to slow down the pace. So that's why in class, we're going to be a lot more hands-on. We're going to apply things a lot more and be able to focus on the learning and not necessarily me lecture, because that's not really learning, is it? So now we're going to jump into the actual topic at hand. This would be a little primer video, just an informative session to get you used to what we're going to be talking about for the next class. Now we're going to do it in this current class here. However, we're going to be able to take notes just like we might be able to at home. And it's really key that we make notes of what we're actually doing, just like we would if we were listening to a class lecture, but you have to do it on your own. So I'm going to try and facilitate in class what type of notes are good notes, maybe why we should copy certain things down that the teacher writes down, what might be more productive, and what can gear you for success at these application problems. So you have a test coming up on the Unit 5 polynomials. So there's a couple outcomes that we need to go over. Alright, so our three outcomes are patterns in relation 5, 6, and 7. First one is students will be expected to demonstrate an understanding of polynomials, limited to polynomials of the degree less than or equal to 2. So that means you're only working with things like x squared or y squared. And in this case here, it's modeling. So can you draw polynomials? Yeah. Can you simplify polynomials? Maybe put them together. Can you match polynomials? So that's what that outcome's talking about. So matching, simplifying, and then also being able to model with algetiles. So I'll give you a question, show me what it looks like. The second one, so patterns of relation 6. So you're expected to model, record, explain operations of adding and subtracting. So essentially you're adding and subtracting polynomials. So you're adding like terms, and you're combining like terms, simplifying, whether it's showing your work with algetiles or symbolically. Okay, so that one means concretely / symbolically. Patterns of relation 7s means you're multiplying or dividing. Okay, so we're multiplying or dividing polynomials using the distributive property. Okay, and that's really key with that. Being able to model it. There's one question that we'll have here today with modeling, along with the typical symbolic work that we see with this course. And this is really important that we understand ourselves here with respect to multiplying and distributive property and dividing, along with adding and subtracting. But a lot of this stuff comes back into play with our grade 10 curriculum next year. So if you have any questions or have any comments, please feel free to comment on the video and I can answer the question. So let's take a look here at our first question. Alright, so we have to use algetiles or algebra tiles to model the polynomial that fits each description. So we're going to sketch the tiles. In this case here, what I'm going to do is use my Mimeo pre-made tiles that I just finished making to sketch / show and model a polynomial. So it says a binomial, so that means two terms, bi meaning two, that contains variables x and y, and a constant term of -2. Well, a constant term of -2, just to clarify, the shaded the shaded blocks are negative, the clear ones are positive. So if I were to make -2, so let's say that there would be -2, okay, so I have -2 ones, and then I might be able to make, let's say, take an x squared and maybe put it like a rectangle, let's say, and let's make a couple of them, and I might be able to say this here would be -3, so this would be -3 x, y, and therefore it has both variables x and y, -2. Oops. So -2. So okay, so that's modeled. So A is done. And it says the other term is -3, and that's how I do that. So the coefficient of the other term is -3. So that's why I have 1, 2, 3 of this. Alright, so for B, we have a trinomial that contains the variable k, and the coefficient of the second degree term is -1. Okay, so that would be -k squared. The coefficient of the first degree term is 1. So instead of saying 1k, I could just say k. And the constant is -8. -8. So here's what this might actually look like. So voila! So we have -k squared plus k, so there's our positive k, and then we have -8, that's the constant, so those are the ones. Okay, so that's how we can model algetiles, model those polynomials. Next up, for each polynomial, write an equivalent polynomial. So that means that instead of saying 5a minus b, we might be able to say something else that might equal the same. Well, instead of saying 5a minus b, a really simple one might be like a plus 4a minus b. It's another polynomial that would also be equivalent to this. If I added these two terms together, I'm going to get 5a minus b. Okay, there's a lot of possibilities with these type of questions, and that's fine. Likewise here with this trinomial, so we have 7q squared minus 2q minus 1. If we were to write this out, we might say, okay, so 6q squared minus 2q minus 5, and I just want to maybe keep going with my work here. I might be able to say, maybe in a vertical row, I should put this in a vertical row here. So we had 6q squared minus 2q minus 5 plus 4 plus q squared. And that equals 7q squared minus 2q minus 1. Okay? So we've written an equivalent polynomial. We just have to take this and rewrite it down here. 7q squared minus 2q minus 1 equals this. Therefore, it's equivalent. I have to show that equal sign. All right. Question 3. Write an expression for the perimeter of this triangle. Simplify the polynomial and determine the perimeter if y equals 3. So let's add all of our terms up. So we have, how many here? So we got 5y squared, because we have 2y squared plus 2y squared, that's 4y squared, plus another y squared, so that's 5y squared, plus 2y. I don't have any y terms there. I got 1 here. I have 1 here, so that's 2y, and then I have 5 plus 5, that's 10. Take away 3, that's 7. Okay, so we have what this expression would be. So we've written the expression for the perimeter. Okay, and I don't even have to really say p equals, but I can. I've now made an equation. And now I'm going to substitute the value of 3 in for y. So if I have 5, 3 squared plus 2 times 3 plus 7, so we have 5, let's show the work here, so 5 times 9 plus 2 times 3, I can actually do this one here together. We got 6 plus 7, so that's 13, and then 5 times 9, that's what, 45. 45 plus 13 is 58. And voila, I am done. Okay, so the perimeter will equal 58 centimeters. Okay, I can also include the a sentence here, but let's quickly see if we can finish one more question here. So create one addition and one subtraction question that gives us this result. So we're only going to be a maximum of actually 15 minutes for our video, so we will stop here and then conclude these questions with another video. So we're on question 4 right now. We have a little ways to go. So most of your videos will only be a maximum of 15 minutes long. That's all I really want to make them. But let's conclude this with a part 2. But welcome to the flipped classroom, and this is what it's like, and this is the kind of stuff you do at home. So you would probably already have the worksheet perhaps, or maybe I'll allow you to print a worksheet, and then you can go ahead and you can have the process down and the application down before you even come to class. All right, see you next time.